All right, so now what we're going to do is turn to chapter 27, which is about stars, and then collections of stars, which are gravitationally bound together. That's actually the definition of a galaxy: stars that are gravitationally bound together. All right, so we'll get to that. Um, all right, and the first thing that we're going to do, by the way, is we'll compare other stars to the sun. That's a very standard thing that we do because, of course, the sun is a star, and it's the star that we know the best. It's obviously the one that's closest to us. We're one astronomical unit away, 1.5 times 10 to the 11th meters away from the sun, and the stars are much, much further away. In fact, you have to use the speed of light, the fastest speed in the universe. Um, it takes light, for example, to get to the nearest star in the sky, which is you can't see it from the northern hemisphere. You got to be in the below the equator to see it. It's called Alpha Centauri, and Alpha Centauri. Well, there's actually three stars orbiting each other: Alpha Centauri, Beta Centauri, and Proxima Centauri. Proxima Centauri is slightly closer to us, but it takes more than 4 years for light, which again is the fastest thing in the universe, to get to Alpha Centauri, or from the light that leaves Alpha Centauri to get to us. All right, so these are the topics we're going to cover. We'll talk about the night sky in general. That we have a lab on that. If you haven't had that lab already. We'll talk about the brightness of stars and the color. The color indicates the temperature. There's a very, very important idea called the Hertzsprung-Russell diagram, or also known as the HR diagram. This gives you the evolution of stars. The entire life cycle of the star can be seen in this thing called the HR diagram. The life cycle of stars, of course, is very much related to that. We'll talk about the death of stars, and which black hole is the most extreme example of the death of a star. There are much more mundane ways that stars die, like our sun, for example, will become what's called a white dwarf when it dies, and we'll see where that is on the HR diagram. Then we'll switch gears here, and we'll talk about entire galaxies. So galaxy, again, is a huge collection of stars. Some small galaxies, there are small, what are sometimes called dwarf galaxies, which have, hundreds of millions of stars, whereas like the Milky Way, which is the galaxy that we live in, has over 100 billion stars, 100 times 10 to the ninth stars. All right, so we'll talk about, and there's other galaxies that are much far bigger than the Milky Way. All right, so when we look out at the night sky, there are these various patterns that humans have identified over the course of generations. Mostly these patterns are tied to the culture of. It has nothing to do with the individual stars or anything like that. So, for example, these 7 stars right here, the ones I'm highlighting right here, these 7 stars are known as. Actually, this is what's called an asterism. All right, so when you have a very familiar part of an overall constellation, it's called an asterism. And so this is probably the most famous asterism of them all. It's called the Big Dipper. All right, so the 7 stars that make up the Big Dipper, this is the handle or the ladle of the Big Dipper. And this is, of course, the cup. These 2 stars right here point to the North Star, which is very important for navigation purposes. Before humans had GPS, the global positioning satellites, they used the North Star, and we still use the North Star. The reason that we use the North Star is it's a relatively bright star. It's not the brightest star in the night sky, but it's a relatively bright star, and it doesn't move night after night. It's as the night progresses, the stars will rise in the east and then set in the west, just like the sun does. But that's really just the rotation of the Earth. Um, so the closer the stars are to the North Pole, so if you extend the North Pole out into space, that's called the celestial North Pole. Those stars actually will just go around the North Pole, and this larger constellation, this constellation, which the Big Dipper is part of it, is called Ursa Major, the Big Bear. All right, so that's the constellation that the Big Dipper is in. As you can see, there's many more stars than just the 7 stars that we call the Big Dipper. And a lot of constellations are like that, where that there's a little part of the constellation that is more recognizable. For example, when you look at the constellation Orion, people usually talk about the belt of Orion. There's these 3 stars that line up. That's only part of the constellation Orion. All right. So as the Earth orbits the sun, of course, we take a little more than 365 days. It's 365, a little bit around a quarter of a day, roughly. As we go around the sun, we see different constellations in the night sky, right? So, and generally, when they talk about like a summer constellation or a winter constellation. So for example, the one I just mentioned, Orion, is a winter constellation. What that means is shortly after sunset in the wintertime, you can go out and see Orion. That doesn't mean you can't see Orion in July or in August. It's just very difficult to see Orion in August, because you might have to wait until 3 or 4 o'clock in the morning before you could actually see it. And then of course, sometimes the constellations that you looked at in the wintertime will be so close to the rising sun or the setting sun that you won't actually be able to see it. But that doesn't really last for very long. So during the course of a night, you can see almost most of the night sky, not the entire thing. Of course, it's the direction of the sun is blocking out the stars, right? The stars are always up there. It's just when we can see them is when the Earth is facing away from the sun, or of course, if there's a solar eclipse. Of course, that happens only rarely. And you have to be in the path of the path of the moon's shadow for that to happen. Of course, that happened in 2017, and that shadow crossed South Carolina. Hopefully, you got to see it. It won't happen again for a very, very long time, at least not crossing South Carolina. All right, so. This is the path that the Earth takes around the sun. Of course, we're spinning counterclockwise around our axis once a day, but we're also going around the sun in a counterclockwise manner. And so are all the planets, right? All the planets are going around the sun this way. And most of the comets and most of the asteroids are also doing that. All right. So so when you look up in the night sky and you see this pattern, some pattern, it doesn't, there's one particular pattern, that's a constellation. And it's kind of fun, going out and looking at identifying the different constellations, but that's not truly astronomy. It's as though, if you were to, arbitrarily fly above the Earth and, pick out different parts of the United States and started naming those areas. Of course, we do that. We call those states. But it's where those states are is, that's more or less, historic. But if you were just flying over the continental United States and you just looked out the window, and I'm going to call this, Fred or something like that. That's pretty arbitrary, and it's the same thing with the constellations, right? It just happens to be where the relatively bright stars are that humans can see, and we can't see all the stars. Normally you have to look up with a telescope, to see some really, really faint stars. So the constellations that we talk about are the stars that are bright enough for us to see with the unaided eye, also known as the naked eye. All right, so sometimes you'll hear me say the naked eye observations. So of course we have these 12 constellations. Well, there's actually 13. Let me state that first of all. There are these 13 constellations where, and you can kind of see, like, when in November, when it's daytime in November, for example, the sun would be, if you looked straight across, the sun would be in these constellations. These aren't representative of any particular constellations, although this one right here looks like Leo. I think they just threw some constellations together. These aren't. Although now that I say that, this one right here looks surprisingly like that actually looks like Capricorn, and that one, oh, maybe they did get it right. This looks a lot like Pisces. Now that I'm looking at these, at any rate, so in November, the sun is in a particular constellation. You can't see that. You can't see the stars in that constellation. So you have to wait until you saw it in October. It was getting closer and closer. That constellation was getting closer and closer to the horizon, and then one day it seemed like the sun moved into that constellation. The sun never moves. From our perspective, it's the Earth revolving around the sun. So it looks like the sun is in these different constellations during the course of the year. Now notice this, the one between November and so you'd be over here, right? So the Earth would be over here. There's a constellation between November and December that people don't really know about very much. Traditionally in November, people talk about Scorpio because the sun used to be in Scorpio, and then in December the sun used to be in the constellation Sagittarius. Now the thing is, that's all shifted. That's shifted because the Earth is actually wobbling, right? And it's not a wobble that you would notice during the course of your lifetime or the course of many, many lifetimes. But the wobble is very, very slow. It takes 26,000 years for the Earth to wobble around once. But it's because the Earth is actually being slowed down. And I mentioned this in the chapter 26. It's being slowed down by the moon, but it's a really slow. It's slowing down at a very slow rate, right? Like 3 milliseconds per century. But over the course of thousands of years, that wobble manifests itself in the night sky. So that if 2,000 years ago, when let's say the Earth was over here and the sun was clearly in the constellation Scorpio, that's actually shifted because of this wobble. The wobble is called precession, by the way, if you were interested. Another thing, so these are the 12 constellations, the traditional 12 constellations of the zodiac. They're not in the right position, so, and there's happens to be another one. Normally the sun is in these constellations for about a month, right? That's where we get the 12 months of the year. But there is a constellation that's between Scorpio and Sagittarius that the sun actually passes